This is section 10.1, and today we're going to actually move into an entire chapter dedicated to circles. So you can leave all that information about four-sided shapes behind and move into circles. Many of these vocab words you've heard before, but a ton of them you have not. So let's start at the beginning where we're going to talk about the center of a circle. I think where we know all that's located is at C or G. You can pick either one. I'll just pick C for now. It's also how we name the circle. So the name of the circle would be circle C. So it's how we name it is where the middle dot is. It's also called the center. And then lots of stuff is actually based off that center. So for radius, one of our radiuses is GE. Another one could be CH or CA. I'll just pick CH for an example, but there are lots there to pick from. And a radius is a segment with endpoints at the center and on the circle. So it has an endpoint at the center and an endpoint on the circle. Any radius does that. Chord is probably a new word for you, one you haven't heard before in terms of circles. And a chord is a segment that has its endpoints on the circle. Which means it does not go outside of the circle. We have a different name for a segment or a line that goes outside the circle. So a chord in this example would be AB. Has its endpoints on the circle. Next up is diameter. That one we've heard before. That's actually a chord that goes through the center. So it's anchored by the center and it goes straight through there. So for us in this picture it would be AD would be our example. So it's just a chord that goes through the center. Next up is secant line. That's probably also a new vocabulary word. Secant lines can look a lot like chords do, and secants just go past the circle. So a secant line is a line that intersects or touches the circle at two places. So for us that would be AB. We're just going to notate it a slightly different way. So up here it was chord that has two ends. Those are on the circle. This is going to be more of a line. It's going to extend beyond the circle. So any segment that, or a line, sorry, any line that kind of extends beyond the circle and cuts right through it, hits it twice, that would be a secant. Tangent line, now we've heard the word tangent before, but that was in context of triangles. This is for circles. And tangent lines just touch the circle one time. So they kind of skim the circle, like they kind of just brush by it, like this one right here, just touches it right at D and keeps going, touches it at E, here this one touches at F and keeps going, touches at H. So it just touches at one point and then kind of moves on. So you got a few tangent lines to pick here. I'll pick DE, this one going on the bottom. Next up is point of tangency. It's just where the tangent touches the circle. So where the tangent and the circle meet. So for us, for that example that I just used with DE, that could be either D or E. That is the point where the tangent touches the circle. I'll just pick D for an example. A common tangent is just a tangent that touches more than one circle. So a tangent shared between circles. Could be lots. Usually we're just talking about two for our purposes, but it could be lots of circles. So a common tangent could be that DE, that same one we were using before. Could also be this HF, because it touches both circles. So I'll just use HF just so you have a different example of a tangent. So that's your vocab today. It's a lot. You probably know 3 out of all of those, so some new vocab for you to learn. So first example is just us naming a few things. So if I looked at AC in this picture, just going from center out, or from, center to the circle, that would be a radius. Number 2 is AB. It's going all the way across the circle, and it goes through the center. That's a diameter. DE is next. DE is outside the circle and just kind of barely skims the circle, so that's our tangent. AE is right here, goes through the circle and extends beyond. There's the A, there's the E, E's outside the circle, so that is our secant. And AG starts and stops on the circle. There's no arrows there, so that's a stopping. So that segment that stops on the circle, oh my gosh, it's called a chord. Sorry, I think I was just speaking at the same time I was trying to write. And then to your theorem card. So on your theorem card, we're going to talk about the first theorem in chapter 10. And forgive me because I don't have my new card yet. We're only looking at this top one. Look at that right there. So, and that looks weird because it's all shiny. So the first theorem that we're going to do is that tangent segments from a common external point are congruent. It's a lot of words to just say if I start at a point and I draw my tangents to the circle, as long as they both come out of that point, they have to be equal to each other. So RS and TS have to be equal. So if you can kind of make, if you turn that a little bit, it makes an ice cream cone. If you're making an ice cream cone down to one single point, then the sides of that cone have to be the same. So make sure you fill that in on your theorem card, and then we're just going to do one quick example. So RS is tangent, and RT is tangent, so they're both tangent to the circle. They're both coming out of R. That means those have to be equal. So 3x plus 4 has to equal 28. We'll subtract 4 from both sides. Leaves me 24. Last step is to divide by 3, so x is 8. So that is your first introduction into circles. Lots of vocab, like I said. One theorem just talking about external tangent segments. So if I make that ice cream cone, the sides of the ice cream cone have to be the same. But just lots of vocab for you to get introduced to.